So I've been working on this project for about 4 months now. And I know I mentioned I was going to make the repository public, but I'm not done with the project yet. So I don't think it would be advisable to do that. I want to finish everything first before I actually release everything. So this is what I'm talking about. Um, so yeah, 4 months ago, right? Started 4 months ago. I actually want to show these two before anything else. Couple QA. Yeah, let's do Gemini. Let's go to results. So over here, you notice that with exact match, we actually got 62%, right? Fuzzy match was 75%. I'm not going to go into the details of everything else. You can just, you can see them. If you understand them, good. If not, don't worry about it. For Gemma, we had 40% exact match, 51% fuzzy match, right? Um, Okay, let's go to Gemma ingestion as well. Uh, Test results. Here again, we had 65% exact match, 76% fuzzy match. So what this basically shows, so this one here is the ingestion was done using Gemma. And over here, no, okay, so this one, the ingestion was done using Gemini, and this one, the ingestion was done using Gemma. And for both of them, when we use Gemini to run the benchmark the evaluation, we had similar results for the EM and the FM, exact match and fuzzy match, which basically goes to show that in terms of the ingestion process, Gemma is quite on par with Gemini. In terms of the um, retrieval process, the actual evaluation, Gemini has the upper hand because even when they use the same information, so let's go here again. Okay, well, even here. So this one, it is the same knowledge graph, is the same knowledge base, and Gemini is using the same knowledge base. It had exact match 65%, fuzzy match 76%. And Gemma on the same knowledge base had exact match 40%, fuzzy match 50%, right? So obviously there is some limitation from Gemma there. But in terms of their knowledge representation capability, in terms of their ingestion capabilities, they seem to be on par. Um, so yes, okay. So I tried two approaches. I tried sub questions and then I tried looping. So the looping is actually there's a different term for it. I don't know why I keep forgetting that term, but it's basically like a loop. So what happens is with a sub question approach, we look at the main question being asked, and then we break it down into sub questions, into sub steps. Basically, what's all the information I need to answer this specific question? Then we represent all those things, all those missing gaps as sub questions. So a question like, who is the what is the role of the woman who acted as Corliss, I think it's Corliss or Coriolis Archer in Kiss and Tell, right? So for a question like that, we need to break it down. Who acted in them? Who acted as um Corliss or Coriolis Archer in the show Kiss and Tell, right? And then the second question is, what was the government position of the person who acted that role? So that's the sub question approach, right? With a looping approach, the way it works is we take the question and then we basically say, okay, so this is the main question. What's it's basically sort of like the sub question approach, just that it's one step at a time. Should I say it like that? Okay, so basically we ask a question, right? So what information do we need to answer this question? So the information might be, okay, who acted that role in that movie, right? Then we look for the information, we get the information, and then we show the LLM. Do you have enough to answer this question? If yes, answer the question. If no, continue the loop. So if it doesn't have enough information, it will continue. What is the next question I can ask? Okay, What government position did the person? Now I know the person. What government position did the person hold? Um, this was, and then it's the system will go. It will go to the retrieval, go and find all the possible answers, give it to the LLM. The LLM will see it and say, okay, so now do I have enough information? If yes, answer the question, answer the main question. If no, continue. Right. So that's the looping approach. Okay, so for the looping approach, so you notice with the sub-question approach, the highest I got was 62% on exact match and 76% on fuzzy match, right? Let me call, okay, 65% on fuzzy exact match and 76% on fuzzy match. Now with the looping approach, let's go to Gemini because that was the best, right? So even with this one, there was even an invalid there was an error in one of the questions, right? But even with that, exact match was 0.62 and fuzzy match was 0.78, right? So the two approaches are almost similar in terms of just the exact match and fuzzy match. Obviously, the F1, the recall, and the precision and stuff like that are different. But like I said, I don't want to go too much into that aspect now. So what I actually did was there were so many issues with the system that I just wasn't happy with. So I had to basically redesign everything. And I started out with GraphRag. I'm still using GraphRag, but I've also incorporated other types of RAG into the system. Now, when I say RAG is retrieval augmented generation. What that basically means is so LLMs generate, well, I mean, I was going to say text, but they don't actually generate text, but just keeping it simple. LLMs generate text and um, they generate that text based on what they have been trained on, right? It's like me being me learning about computer science, software engineering. I can only tell you about software engineering. I cannot tell you about medicine, right? So my information is limited. I cannot tell you anything about medicine. If I wanted to answer a question that was medicine related, I might need to maybe refer to the internet or refer to a textbook or something. So that is RAG. RAG is giving LLMs the ability to fetch information, right? Look at new information, not within its own context, not within its own brain, in a sense, to actually use that information and answer a question, right? To generate text based on the new context that has been given. Okay, so basically, it is still the same generation, but now it is being augmented. It is being helped by retrieval, the retrieval of extra information, right? Retrieval augmented generation. Okay, so there are various types of RAG. There's corrective RAG, there's agentic RAG, and agentic RAG is actually proven to be one of the best so far, mainly because it works on both the context you give it and then also has the ability to do web search. And I mean, getting information, getting more resources from the internet is actually quite helpful because if we as human beings, when we are looking for information about something, we want to find out about something, we just go into the internet, Google, Bing, DuckDuckGo, whichever one you use, you just search what you're looking for, read the various articles, and then, come up, find the answer you're looking for. The LLMs basically just, you can do that now with the LLMs, right? You ask a question. So you can go into ChatGPT, for instance, you ask a question, it does web search behind the scenes. If it doesn't know the answer to your specific question, to try and get the information it needs to actually answer your question, right? So that's the web search aspect. Agentic RAG. Okay, so I mean, there are various types of RAG. So I was using Graph RAG specifically, but now I'm actually incorporating other types of RAG as well. But I'll not go into that aspect yet because that's on the retrieval side, right? I have finally, I believe, reached the point within the ingestion process that I'm actually quite comfortable with. And what I mean by that is, so the ingestion process is actually the represent so the processing of the data that is fed into the system and the representation of that data in a way that um, it doesn't overwhelm the LLM and also makes sense to the LLM, right? So when it comes to RAG, right? There are various approaches you could use. You could use chunking. If you have large documents, you could use chunking. And what that basically means is you take the document and then you break it up into pieces and you embed those chunks, right? Embedding basically is just representing the information in let me see vectors, right? Basically in numbers, right? Because it's easier for the computer system to understand numbers than it is to understand just raw text, right? Okay, so you embed those chunks, and then when the LLM is looking for the information it needs to answer a question, it will use vector similarity. So basically, it will take your question, embed your question, and then find the specific chunk within the system that has a high similarity in its embedding to the embedding of the question you asked. Right. So I mean, with every implementation, there's an advantage and there's a disadvantage. So the problem with chunking is when you break the document into pieces, you might lose certain context that might be linked to other context. So let's say you have a paragraph about um, API design, right? Maybe the second paragraph could be talking about how to um, the do's and don'ts of how to structure routes within an API. And if you break the chunks in a way that the first paragraph and the second paragraph are in separate chunks, the information might be disjoint in such a way that when the LLM is looking for you ask it a specific question and it's looking for an answer, it might get just the first chunk and it's not get the second chunk. And then the information it has would be fragmented, it would be broken, right? So GraphRag basically seeks to solve this by representing information in entities and relationships because no one thing is an island on its own, right? So you have okay, so now let's actually go into the system. Okay, reload. Okay. Usually it starts in the middle. I don't know why this time it started. Okay, there we go. Okay, so actually I think I should just get rid of my fees completely. Good. Okay, so here we go. This is the graphical representation of the knowledge within the system. So we have entities and then they are linked together with relationships, right? So here we have Lyndon Johnson. What is the context for Lyndon Johnson? Lyndon Johnson was the vice president who chaired the President's Committee on Equal Employment Opportunity. Yeah, right. Okay, so with something like this, okay, so I am not 100% can, what word should I use? Confident in the ingestion process because something like this, right? Vice president of what country? It doesn't state that, right? So there's still some missing information in there that I feel could potentially be solved if I were to if I just spend a little bit more time trying to improve the ingestion process. But I think I'm at a point where I am confident enough to move on to the next stage, right? But anyway, so this is Lyndon Johnson. That's the entity, Lyndon Johnson. And right now, so if you take a look at the bottom of the screen, you'll notice the controls for the system or the controls for this page. It's basically like a game where you have a 3D character moving in 3D space. So you can move the camera around, you can move forward, you can move backward, you can move left, you can move right, you can additionally move up and down, right? Okay, so Weekly Shonen Jump. Weekly Shonen Jump is a Japanese manga magazine in which the Prince of Tennis was first published. Okay, interesting. So I want to find, let me see, Lyndon Johnson. Is Lyndon Johnson? Oh, interesting. Lyndon Johnson isn't linked to anything. Interesting. Okay, I'm trying to find a node that is linked to something else. Okay, 5th December looks to be linked to, looks like it's linked to something else. Okay, so 5th December 1948 is the date of birth for John Home Robertson. Represents a specific point in time associated with his life. Okay, so now if we trace the connection here, I am expecting it is linked to the person was mentioned, right? Robertson. So let's follow the link. Try not to lose it. Actually, I think one extra thing I could add is oops. I think one extra thing I could add is highlighting. So when you click on a node, it highlights the oh, interesting. The link is actually to a community. So this is the community. Hmm, that's interesting. I guess it's not, but okay. Maybe it is not at a place that I'm fully confident in yet. Uh, okay, let's see. Lists Opera and lists consulted. Okay, let's check this. These seem to be linked. Lists consulted refers to a compilation of lists of significant opera composers used as the basis for determining major composers. Okay, and then we have opera. Opera is the genre of music that Giuseppe Verdi composed. It represents his primary creative output and professional domain. Opera is a resource for an introduction to operatic history. Okay, so something like this, you can clearly see the links here, right? I'm not sure if you can see the link, but let me see if I can. Yeah, okay, so this is it, right? You can see the link here. So Opera is linked to List Consulted, which also has context about Opera. And then Opera is also connected to um, some other nodes within the system. Okay, let's try and follow this one. Let's see. Oh, is this it? Um, oh no, it keeps going. Okay, so it's connected to this node over here. Jacopo Perry. I don't know how to pronounce that name, but let's see the context. Jacopo Perry is considered the first ever opera composer, writing the first opera. Okay, good. So you can see over here, right? It is actually making the correct connections. So it connected opera with Jacopo Perry, who was an opera composer, right? So that's basically how the system is supposed to work. Okay, so I mean, this is just a this. So yes, this is for the ingestion process, which basically takes all the information that is fed into the system and breaks it apart into entities and their context and their relationships to each other. Um, yeah, and this is the graphical representation for that. Okay, so moving forward, what I want to do is I actually didn't talk about something. So we have communities. I think I mentioned that, right? We have communities as well. So communities, we have three levels of communities. And basically, okay, so let's go to that huge community we saw. So communities are a collection of nodes that talk about something. Like they share some sort of commonality between them, right? They all talk about one collective thing. So over here we see Chinese railway networks and international relations. So it's this collection of entities, details a fascinating web of geographical locations, administrative regions, and international relations centered around China's railway infrastructure, blah 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 blah. Right. Um, Yeah, so there are three levels of communities, and I mean, each level is just a broader one. So we have the base level that's like maybe 5 to 10 nodes. Then we have the next level, which is like a broader one. You would probably have like, let's say, maybe 10 to 50 nodes. And then we have the highest level, which is the broadest, which has like so many. So you can even see it here. There are so many connections to this community, right? So this is the broadest level. Okay. Yeah. So moving forward, I want to focus more on the retrieval portion because I think, like I said, I've reached a point that I'm a bit confident in the ingestion process. It's the ingestion process that represents the knowledge in a way that the retriever is able to get and then give to the LLM for the LLM to actually make sense of the context and then answer the question that's been asked. And I'm using the hotspot QA dataset, and it's basically just like Wikipedia pages that have been prepared specifically for testing these sorts of things. Cool. So yeah, um, I will be working on the retrieval aspect next. My plan is to try and optimize it enough to the extent that mm, I don't know if near perfect is possible, because the industry standard seems to be around, it used to be, I think, 60-ish percent, but now it seems to be around 75-ish percent. Let's see if we can push that to 80, maybe 90, right? Anyway, so yeah, this is what I've gotten to. Hopefully, I finish this early and then I can just release everything. If not, I mean, we just keep going until we get to the end eventually. But yeah, okay, so thanks for tuning in and being updated on my progress.